to discussion about the one of the important concepts, that electric field now. Electric field or electric field intensity. See, it's a most important concept in that electrostatics. Of course, that all are the important one for the PU students. Every point you try to understand the concept. See, the electric field. What is meant by the field? In general, how to define the field? Yes, in this case, what happens now? If suppose you may able to take, how to define the field? You are supposed to use field. Often you are using the field, that word field. How? There is some space. For example, some space surrounded by that any object. For example, that yourself you may able to take. Some space surrounded by you. That is what? Your field. Isn't it? It's your field. You may able to take that one object. Say, this is that object. The space surrounded by this object, that's what? Its field. Now, the electric field now. It's a simple one. The space surrounded by that charge or system of charges within which the other charged particles experience some force. Say that force, the electrostatic force you may call it. You know the electrostatic force of attraction or repulsion. So far, in another one, force experienced on unit positive charge. Force experienced on unit positive charge, that is what we call it now, that electric field or electric field intensity. So far in this case, let me take plus Q be that charge or source charge. It produces that electric field. Say plus Q be the point charge which is placed some that medium, that's what no, that air medium. In this case what? This is the plus Q. It's a point charge or source charge. It produces that electric field. Obviously, because some space surrounded by this charge. Let me take this is the charge. So for some space surrounded by this charge, that's what the electric field will be produces. So in this case, then this is what now the plus Q naught that I said. This is at point P, you may call it. This is a test charge. It should be very small as possible. So far, what is meant by this test charge? That's a simple question. Say point charge. Of course, the Coulomb explained about this electric force concept, that Coulomb's law explained by taking what no, that point charges. So that's a source charge you may call. That point charge, the space surrounded by this point charge, there is some electric field will be produced. Okay, the test charge plus Q naught be the test charge. What is meant by the test charge? Simple way for any explanation regarding that electric field concept, we may able to use. Say the test charge plus Q naught be the test charge, we can able to use. What is the test charge? It's a very simple concept. If I say this is the test charge, you should think there is some presence of electric field. Innovative. Test charge anta let us consider that Q naught plus Q naught be the test charge anta helidaga nimagu gottagbeku, yes, there is some electric field, presence of electric field. So ultimately the test charge, what it means, it detects the presence of electric field. That's a basic concept that what we can able to see. Then about this electric field concept, very first time, its electric field concept it was given by Faraday. First he introduced the concept of electric field, which is physical reality. Faraday explained about introduced this particular concept, that's electric field. And one more thing that we have been discussed very first class only, some properties of electric charges and some methods of electric charging, say electrification method, that all we have been discussed very first class only. So far there is some more that attraction and repulsion concept that we have been discussed, attraction as well as repulsion. So far, with reference to that all these things, how the attraction and repulsion, it totally depending on nature of charges, we know that already. That one more question we are going to expecting many times, especially for the examination. It's a simple question for the competitive examination. Say, Shear test of electrification. What is the Shear test of electrification? You must know that. Ultimately, what we came to know that, say for Shear test of electrification is what we call repulsion. We can able to say in methods of charging also, by rubbing process, conduction process and induction process. You know what is meant by the electrification concept. If you know that electrification concept, then we can able to visualize the things. Electrification. What is the Shear test of electrification? You must know the repulsion. Say, for example, by taking that two bodies having some masses M1 and M2 separated by certain distance, as I told in the discussion about mass as well as that charge, in which what we came to know that there is some force of attraction is there. The gravitational force, that's only the attractive force. As usual, we know that. But in the Coulomb's law, of course, that electrostatic force of attraction as well as repulsion. That's what in the electrostatic about the charge concept. Whether they are in like charges and unlike charges, in which the force of attraction as well as the repulsion. But we are supposed to say Shear test of electrification is what we call the repulsion. See, especially for the electric field concept, we must try to understand in the examination point of view about electric field. There are some more the concepts, some more the points which you can able to remember. See about what is meant by that electric field, what is the expression for that electric field, what is SI unit of this electric field, and dimensional formula of this electric field, and whether it is a vector quantity or say scalar quantity. At least about these 5 more points you try to understand about the electric field concept. See, as usual we know that, say about this electric field concept, we came to know that, say that definition we know. Then, see that formula, that electric field, E equal to F divided by Q naught. F is that force experienced on unit positive charge. Q naught, that's a test charge. Force divided by the charge. Say that unit charge, test charge you can say, unit positive charge you may say, or test charge you can say. E equal to F divided by Q naught. See, that's the first important thing, that formula. The next one, about this electric field, whether it is a scalar quantity or vector quantity. Electric field is a vector quantity. It's a vector. So far, in this vector, means already we told that we studied electric field is the vector quantity, because vector quantity is nothing but in which having both magnitude as well as direction. You should have both magnitude and direction. Electric field, it should have both magnitude and direction, hence it is the vector quantity. So far, the next one, SI unit of this electric field. SI unit. Say force and charge, that should be what? Newton per coulomb. Newton per coulomb is the SI unit of this electric field now. So far with reference to this, let me take with reference to this, SI unit of this electric field is Newton per coulomb. The next one is dimensional formula. So the dimensional formula, how to write the dimensional formula? As I told earlier also, in the first PUC, you all studied about the dimensional, how to write the dimensional formula. To write the dimensional formula of any physical quantity, you try to understand the first thing, formula of the physical quantity. Better you try to know that definition or SI unit. Based on that, you can directly write the dimensional formula of the physical quantity. See, then I will tell you here. E equal to F divided by Q. That's electric field. That's a formula of this electric field. Force is nothing but mass into acceleration. This is the charge Q. Simple thing. How to write the dimensional formula of this physical quantity. Say mass, so far M1. A acceleration, its SI unit is meter per second square. Meter means L1 second square per second square minus 2. Charge is 80. Correct? Is it clear now? So far M1, L1, T minus 2. This is the dimensional formula for this force. To write the dimensional formula for that force, you must know what is the force. F equal to ma. Then charge, its dimensional formula is 80. Then we can write, say, dimensional formula for this electric field is, say, M1, L1, T minus 3, T minus 2, and this one is minus 1. Minus 3, A minus 1. This is the dimensional formula for this physical quantity. That physical quantity is electric field now. Okay? You try to understand. See, it's a most important one about this electric field. Electric field ಅಂದ ತಕ್ಷಣ at least ನಿಮಗೆ ಒಂದು 4-5 ಪಾಯಿಂಟ್ಸ್ ಗೊತ್ತಿರಬೇಕು. So, ಏನಪ್ಪ electric field ಅಂತಂದ್ರೆ, say, definition of electric field, some space surrounded by that charge. Then its formula, then whether it's a vector or scalar, you must say it's a vector quantity, and SI unit, dimensional formula of the physical quantity. You try to know that. After discussion about that electric potential, then you can able to compare electric field and potential concept. See, that we have been discussed about the electric field concept. See that electric field formula, it's a vector quantity, SI unit, and also the dimensional formula that we have been discussed. Now, very important thing, that is one simple derivation. That's what electric field due to the point charge. Electric field due to the point charge. By taking that point charge, what is electric field due to that point charge? See, it's a simple derivation. Let me know that what actually here. Electric field at a point due to the point charge. For example, the derivation electric field due to the point charge means what? Electric field at a point due to point charge. So for here, let us consider, say, point charge plus Q, point charge plus Q at O in free space. Say, plus Q be the point charge placed at O in a free space. The secondly, P be the point at a distance R from this point charge plus Q. Next point, let Q naught be the test charge placed at P point. So far, there must be some force will act on this plus Q charge, then also we can able to write. As usual, this is the plus Q, the Q naught with the test charge, and it is the plus Q. Both are separated by distance is R. Then what happens now here? These two are the charges, separated by distance is so R. We know the Coulomb's law. Just to apply the Coulomb's law, we know the Coulomb's law. That's what F equal to 1 divided by 4 pi F naught Q1 Q2 divided by R square. Those 2 point charges placed in the air medium. Of course, this one is also placed in the air medium. According to the Coulomb's law, then we can write F equal to 1 divided by 4 pi F naught Q naught divided by R square. Then R is the unit vector. That we can able to write in the vector form. So, where R is the unit vector directed from plus Q to that plus Q naught. This is what in this particular direction. We have the definition of electric field. We know that some force experienced on unit positive charge. That's electric field definition. Say E equal to F divided by Q naught. We know the Coulomb's law. Then already we have that expression. In this expression, F equal to 1 divided by 4 pi F naught. Say Q naught divided by R square into unit vector. Just we have that electric field expression. E equal to F divided by Q naught. Just to substitute that F value in this. So far, 1 divided by 4 pi F naught. Q naught divided by R square into Q naught. Say unit vector. Say Q naught get cancelled. Now 1 divided by 4 pi F naught. Q divided by R square into the unit vector. See that electric field at a point due to that point charge, then expression E equal to 1 divided by 4 pi F naught Q divided by R square. So this is for that air medium. In that medium, again you can able to use the dielectric medium concept. That also you can able to write. So it's the most important expression. Always you can able to do this one. How? How it is E? E is related with distance, say R square. E is inversely proportional to R square. Say that E depends on what? Magnitude of plus Q. Of course, this is the Q. Not depends on the test charge. Whatever the test charge, but E is not depending on the test charge. It is depending on that magnitude of the charge. So far, this electric field concept is a property of space and not of the charge testing the field. So that is also one of the important concepts. These note factors are also very important for the competitive examination point of view. Even also board examination. Last twice they have been asked regarding this one. How? Say that point charge, if the point charge, how it should be. Let us consider center of the sphere located at point charge. Then what happens? It's directed outward if the charge is positive. So this charge is positive. Ultimately what happens? It's directed outwards. Simple diagram they have been asked. If the charge is negative, ultimately it is inward. It is directed inward if the charge is negative. So far, this is the basic thing about the electric field concept. And most important derivation, it's a basic fundamental derivation that we try to understand about electric field at a point due to point charge E equal to 1 divided by 4 pi F naught Q divided by R square. That's a unit vector. So in this session that we have been discussion about the electric field concept and electric field at a point due to point charge. That's what electric field due to the point charge. That expression also we have been discussing now. See, these are all the things. ನಾವು ಹೇಳ್ತಾ ಇರ್ತೀವಿ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತಂದಾಗ ನಿಮ್ಗೆ ಎಲ್ಲಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆದ ತಕ್ಷಣ ಮೆಮೊರಿ ಒಳಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಬಗ್ಗೆ ಇರುವಂತ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ಸ್ ಕೂಡ ರಿಕಾಲ್ ಆಗಬೇಕು. ಮತ್ತೆ ಯಾವುದೇ ಡೆರಿವೇಶನ್ ಅನ್ನು ಕೂಡ ಡಿರೈವ್ ಮಾಡಬೇಕಂತಂದ್ರೆ ಈ ಮುಂಚೆ ನಾವು ಯಾವುದೇ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಕಲ್ತಿರ್ತೀವಲ್ಲ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಡೆರಿವೇಶನ್ ಅನ್ನ ಡಿರೈವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅಂದ್ರೆ ಪ್ರತಿಯೊಂದು ಡೆರಿವೇಶನ್ ಕೂಡ ಲಿಂಕ್ ಇರ್ತಾವ. ಅದಕ್ಕೆ ಪ್ರತಿಯೊಬ್ಬರು ಕೂಡ ಅಪ್ ಟು ಡೇಟ್ ನೀವು ವರ್ಕ್ ಮಾಡ್ತಾ ಹೋದಾಗ ಫಿಸಿಕ್ಸ್ ನಲ್ಲಿ ಎಲ್ಲಾ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಚೆನ್ನಾಗಿ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. Okay, so this today that in this session that we have been discussion about the electric field and electric field at a point due to point charge.